Welcome back to HVAC for Beginners. My name is Chris and I'm your instructor for this video. Today we are going to go over HVAC condenser contactor. So the contactor on the HVAC system is usually on a certain side of the condensing unit that's outdoors. And how you would notice it, if you've never seen one before, it'd be the only thing that's either on either side of your house or in the backyard that has some copper tubing connected to it. You might see a disconnect box to it and a concrete pad underneath it. That is your outside condensing unit. And then there's a little platform that has a door that usually has 4 screws or 2 screws, usually 5/16, and you just unscrew the bottom ones, loosen the top ones, and pull the panel off, and you'll get access to the electrical panel on that condensing unit. Now, we're going to go over what does the contactor actually do? What is its actual job that it does? And also, how long of a lifespan does a contactor actually have? But first, let's kind of go over the aspects of what does a contactor do. Well, an HV contactor plays a crucial role in the operation of your condensing unit, which is a part of the HVAC system responsible for cooling or heating a space. A contactor is an electrical relay that controls the flow of electrical power to the compressor, condenser, fan motor, and other components within the condensing unit. When the thermostat signals a need for cooling or heating, the contactor receives an electrical signal from the HVAC system control board or thermostat. The contactor then engages and allows electrical current to flow from the main power source to the compressor and the condenser and the fan motor. So its primary function on the contactor is to facilitate the switching of high voltage power to the components when the contactor is energized. It closes the contacts, allowing the electric current to flow through the system. This allows the compressor to start running, generate the cooling or heating effect, and the condenser fan motor to circulate air across to the condenser coil for heat dissipation. Once the desired temperature is reached, our thermostat signal shuts down. The control signal to the contactor is interrupted and it's open to the contacts, cutting off the power supplied to the compressor and the condenser and fan motor. This process helps controlling the operation of the condensing unit and maintaining the desired temperature in the space. Overall, the HVAC contactor is a central component that enables the electrical control for the condensing unit, allowing for efficient operation and temperature regulations within the HVAC system. So let's go over a few things that it had specified. Now it said a signal and needs for heating and cooling. So let me kind of give you 2 scenarios of what they're talking about. There are HVAC systems that what we call are direct heat and cool. And basically what that is it the indoor unit heats the inside, no matter if it's an electrical air handler or if it's a gas furnace, and then that condenser outside is strictly used for cooling. But there are units that you can buy that are called heat pumps. And basically a simple breakdown, because we will go over heat pumps in the future. The heat pump is designed to run in the spring, summer, winter, and fall when need be. So in the summertime, it runs the air conditioning system like it is. In the fall, it'll do the same. But when it gets into the wintertime, a heat pump at a certain range can be set where it basically has what's called a reversing valve. And it reverses the flow and actually turns the condenser outside, the coil, into an evaporator. And then the indoor coil becomes the condenser, which actually pulls heat inside without engaging any kind of heat strips. It actually uses emergency thermostat or control, and basically the outdoor unit has a defrost board because that condenser will freeze up out there, and then when it's done it'll switch on the reversing valve and then de-ice the outside unit. So that's why it's saying heating. Heat pump is a different element altogether, and we will get into that. Now when it specifies control voltage, okay, Anything that is control voltage is going to be low voltage. 24 volts in this system for a residential home system is 24 volts. That's basically, it feeds your thermostat, your board cycle that's inside your furnace, and then the contactor that it feeds to outside. So basically, what happens is when the 24 volts is fed to one side of each of the contactor, it allows it to engage the coil on it, introducing magnetism, pulls the contactor in, and then it allows the main voltage to feed through and energize the condensing unit for cooling operations and or heating if you have a heat pump. So let's go ahead and take a look at two different styles of contactor. One is called a single pole, the other one's called a dual pole. So let's kind of go into the aspect. If you look at a single pole contactor, you will see that lowercase area, you'll see a red and black wire coming in. Well, that's the feed that's coming, the direct feed from the home. It means it's coming from a disconnect box, and it feeds on one side of the contactor on the bottom. And then on the top side is where the connecting wires or voltage wires from your compressor, your condenser fan motor are fed over. And it is red and black as well. So you have three wires off your compressor: your common, your start, and your run. Okay. One of those three wires, which is the yellow wire there's a capacitor on the right hand side. That's the gray one. There's a yellow wire that feeds off of that. So you see two of them. One's coming from the fan, one's coming from the compressor. Will feed over to a split capacitor, and it usually goes on the hermetic side of the capacitor, which completes the circuit of the compressor. The condenser fan motor has one that goes over to the capacitor, and it says fan. The other two go in there that feed over to the far side, and it gets power from it. Now, you know, depending on fan motors, and we'll get into that, they're either 3-wire, which is usually factory, or 4-wire, which is universal. But let's go over the contactor itself. If you notice on each side, you see a brown wire connecting on the left side. You'll see another brown wire feeding over to the right side of this one. And that is your 24 volts that's feeding in from the indoor unit. That's that common, the common and cool, which is your Y. Those two that are connected runs outside and then feeds to the wires. Now you see the little blue wire nuts? Or there's the red and white are connected to the brown, and it feeds to the contactor. And that's where it makes its splice. Reason why this is a single pole is on the left side, it has direct feed from the high voltage coming from the home. So basically, it's allowing one side of that contactor to be energized, where the other side does not energize and engage until it is actually calling for cool, which, if you notice in the right hand side, you'll see the little platform in the middle, little metal black emblem, a little copper tab is. That's where it pulls the contact to complete the circuit of the high voltage, and it runs all the way through, and then the condenser itself will engage. Now, there are many reasons why some people use a single pole. Some compressors will have what we call a heat strap down below, and it actually feeds the bottom of that compressor and kind of keeps the oil in it warm, and so it doesn't energize a thick certain amount of oil. Me personally, I always use dual poles. It's, you know, if I need to run that strap, I can run it where it has a constant feed and keep it running without it having to be energized in that manner. But it's basically a single pole, means that the pole, it only has one pole on the right side. And then on the other side where it says double pole contactor, basically it's the same thing as a single pole, except it has two contacts. And the reason why I like using dual pole is because it has two contacts, and it allows for that contactor to last longer. That means it has two poles of contact instead of one. That means I can get almost double the life out of that one, as long as it's, you know, maintained and taken care of properly. And it's the same setup, as you can tell if you look over. And then, of course, looks like on this one here, he's unstrapped the capacitor, probably went bad, or he was testing it, one of those two. So let's look at a single pole. A single pole for a home, a residential home, is 40 VAs, 24 volt, 208, 230. So, like I said, the little single connections on each side of the contactor are what feed for your 24 volt in from the home. And then the main voltage comes in from one side, feeds in, and then all the parts on your condensing unit, your fan, compressor, all connect to that side, and the lead that feeds over to your capacitor. So it all feeds those as well. And for a dual pole, it's the same thing. It's still 40 VA, 24 volt. Still has the same contact. As you know, if you look down there, it says 24 volt contact. It even has it marked on it. It's still 208, 230 volt feed, and it's still identical in every way. The only difference between them is one single pole, which has single point of contact. The other one is dual pole, has a dual point of contact. And they're extremely popular. And they, without the contactor, there would be no access to engaging the outside condensing unit. These things, since they contact in and out quite a bit, especially in the summer months, they will get pitted and burned. They are common to weld themselves together. I've actually gone out where the condenser is running outside and it's freezing up because the indoor unit has satisfied, but the points had welded shut on the contactor and the condenser just kept on running, which is a simple fix. You go out, you turn it off, you pop them loose, and you replace the contactor, and that solves that issue. It's a real simple transaction to have done. But that's how a contactor works. It's real simple and basic. This one's not going to be a long video because there's just not a whole lot to it. The nomenclature on these is the white tab that you see on each one gives you the breakdown information of that contactor. They do make 75 VA contactors out there. You know, a lot of them are used in the commercial field. Some are used in the residential field, just depending on the situation at hand. Well, I hope that gets you a good understanding on what a contactor is. There's not a whole lot to it. All a contactor basically does is it electrifies, it makes magnetism, it pulls the contactor in, it allows the high voltage 208, 230, 220 volt as we call it, to circulate through the system and allows the condensing unit to operate. So with that, guys, I hope you understand a little bit about a contactor. If you get a chance, go outside and take a look at yours. Just do not stick your hand in it whatsoever. I don't advise that. There's a little disconnect out there. If you pull it, it either has a breaker style switch on it or it has a pull tab. We call it a duck bill. You pull that out and that'll kill the power to it, and it'll allow you to take a look at it in a little more safe manner. So with that, guys, this is Chris with HVAC for Beginners. We will see you on the next video.